And we know in this case, let me get my pen again. We know in this case that it returned to its original position after like 2 seconds faster. So it got there faster. I don't know why this isn't drawing for me anymore. There we go. So in this case, if it got there 2 seconds faster, it got there twice as fast. That means it's probably driving twice as fast. So I would go down to negative 4 meters per second for 2 seconds. Right? That one almost tricked me there. Then you end up at 8 seconds. And make sure you put your numbers in here too. Yeah, but that part might trick you up because it's moving for 4 seconds to start, and then it gets back to its original position in 2 seconds. That means it's moving twice as fast. So it means you need to double your velocity. You need to go in the negative direction. And for your motion map, I might skip that for now because again, your teacher might tell you how to draw this a little bit differently. We'll give it a shot. So again, if this is 0 meters, this is 1, this is 2, this is 3, 4, 5, 6, 7, and then 8 would be over here. If we're copying this picture down here, object moves with a constant positive velocity for 4 seconds. You'd have your dot right here, and then you have your arrow 1. Let me see if I can do this with my mouse a little easier. It's not letting me write. There we go. 1. You have another dot right here. 2. Another dot right here. 3. Another dot right here. 4. Stops for 2 seconds, and this is where maybe he wants you to put 2 dots like this, and then starts moving backwards. 1. Actually, it starts moving backwards faster. 1. 2 arrows. Maybe it's like that. I don't know. Ask your teacher about that one. Now down here, they do have that motion map to start. So let's go down. And from what I infer from this is I think I can type on here. Let me see if I can type a little message text. Here it is. So what it looks like it's saying is, again, I'm not sure where they start. I'm guessing they start it up here. So there's this 1, 2, 3, 4, 5, 6 meters. So we'll say a person is moving. Backwards. There's a lot of different ways that you can write this. A person is moving backwards. It looks like at a constant. You kind of just want to copy a lot of the language. Velocity. A person is moving backwards at a constant velocity. And it looks like each dot, it says t is 1 second for 3 seconds. 3 seconds. Right, and they stop for, make this a little smaller. They stop for maybe 2 seconds. That's what that is. Then they move forward for it looks like they're moving at half the speed. Forward at half the speed for 1, 2, 3, 4 seconds. I guess 4 seconds. Seconds. 1, 2, 3. This is 1, 2. 1, 2. This might be 2 seconds. makes more sense. So I'm like, you can kind of read through this and sort of understand why I put it there. They're moving backwards, constant velocity, and that's not changing. The amount of arrows, that's not changing, for 2 seconds. 1, 2 seconds. Looks like they stop for 2 seconds. 1, 2 seconds. And then they move back 1, 2, 3. And I'm assuming that's half the speed, because you're moving 2 meters in this case, and you're moving 1 meter for this case. I don't know. You might want to reword it to make it make more sense. Okay, so drawing this graph is again pretty similar. You have your meters here: 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 6 meters. You're starting at 2, 3, 4, 5, 6. You're starting at this position right here, this 6 meter position. You're moving backwards. Let's see, 2 meters, it looks like, every 1 second. So we'll go here, and we'll go here. Another second. Go down 2 more meters. Right? And it looks like they stop right here at this 2 meter mark. For 2 seconds, maybe. 1, 2. And we'll just connect the lines in a little bit. And then it looks like they move forward again in distance, 1 meter per second. So 1, 2, 3, 4. I'm just kind of eyeballing it. 2, 3, 4. So you can connect the lines and it'll look something like this. Then for the velocity, again, you have something pretty similar. What we talked about earlier is that the slope of the velocity changes the speed of the velocity. Remember, you're going to have kind of a lot of horizontal lines for here. Right, so for the first 2 seconds, they're moving at a velocity of, and we said this, 2 meters, 2 meters per second. However, they're starting off moving backwards, so this would be negative 2 meters per second. And they're doing that for 2 seconds. Right? So it would look like this. Then they stand still, so it goes to 0 meters per second for 2 seconds. 1, 2. Then they go forward, right? They go forward velocity, 1 meter per second. This is 1, 2. They go forward 1 meter per second for, what is that, 1, 2, 3 seconds. The graph might look something like that. Okay, the only thing that was really confusing is the written description. You can get a lot of different answers for that. All right, moving on to the next one. This page right here is displacement. This motion map shows the position of an object every 1 second. From the motion map, answer the following. So we have describe the motion of an object. And it looks like, I don't really like the way these arrows look. It looks, to me, I'll go ahead and type this in. Make this a little smaller, down here, make it longer. The motion of an object, it looks like, I'll have to type it down here so that doesn't get in the way. An object, we always know an object is probably moving if it's moving forward in space. Is moving. Let's see, how many meters is that? That's 1, 2. Yeah, 2 meters. And I'm assuming this is a unit for a second. Every second. For 1, 2, 3 seconds. For 3 seconds. That's what that motion map looks like to me. Then we can go ahead and draw some pictures in here. Represent the motion with the quantitative x versus t graph. Again, this is going to be meters per second. Meters per second. Again, I always like to have my units here. This is likely going to be meters per second or velocity per second. So to represent this motion with a quantitative xt graph, they're starting at 2 meters. 1, 2. Again, I would recommend you write your numbers in here. And then they go 2 meters every 1 second. 1 second is going to be 2 meters later. 1 second is going to be 2 meters later. And your graph stops there, so personally I wouldn't go any further. I mean, you can continue the graph up here, but you'd have to draw a line up here. And then represent the motion with the quantitative v versus t graph. So this is constant velocity, right? So we said they're moving 2 meters per second. So 1, 2. And they're doing that for 1, 2, 3 seconds. 1, 2, 3 seconds. So I do something like that. And this part I might not be correct on. So again, ask your teacher. I'm not sure what they're asking here. Write a mathematical expression that represents the relationship between position and time. So position and time. I would guess that they're asking you to write meters per second, right? Because that's position versus time. Meters per second, or meters divided by seconds. For the position time graph, find the displacement from 1 second to 3 seconds. So from 1 second to 3 seconds, how much distance passed? That's what I'm assuming displacement means. How much distance passed from 1 second to 3 seconds? And we can just look at our graph and we can say that 1, 2, 3, 4. We can say 4 meters passed. 4 meters. You can probably use this mathematical expression to figure that out too. Find the area under the velocity time graph from t equals 1 second to t equals 3 seconds. What are the units for area? Describe what this area represents. So from time equals 1 second to time equals 3 seconds. Again, I'm not entirely sure what they're asking. Maybe they're asking for this area down here, and that would be the meters per second squared thing again. But I'm really not too sure what your teacher's asking for these 3 questions, so these might not be correct. Okay, and then finally, I think that was at the last page. Let's see. One more page down here. Given one motion representation, supply the missing motion representations. I might just have you do this page on your own, because by now you should be able to understand this part. If you don't, you can type it in the chat. Okay, hopefully that helped.